Assalamualaikum and hello everyone. Welcome to the video for 3.3 Electrolytic Cell. In this video, we will learn to draw an electrolytic cell, describe the operation, explain of the factor of the standard reduction potential, the concentration of the species and the nature of the electrode, on the selective discharge. And then last but not least is to predict the electrolysis of molten salt and water. Okay, so without further ado, let's look what is electrolysis. Electrolysis is a chemical process that uses electricity to cause a non-spontaneous redox reaction to occur. So when we're talking about use electricity, so for the case of electrolysis, we do have battery connected to our electrode. Okay, here it mentioned to cause a non-spontaneous redox reaction because if the electrode is not connected to the battery, the reaction would not occur. So that's why here cause a non-spontaneous. But when there is the presence of electricity, this reaction can happen. Okay, so an electrolytic cell is made up of two electrodes connected to a battery and immersed in an electrolyte, where the electrolyte is the liquid which conducts electricity due to the presence of positive and negative ion. So positive and negative ion, just to remind you, positive is your cation and your negative ion is your anion. Okay, so let's look here about the anode and cathode. Okay, for the case of electrolytic cell, the positive anode is your positive terminal. And that is the electrode which is connected to the positive terminal of the battery. Hence, it is called positive terminal. Okay, again, based upon our 3.1, we know that anodes. Okay, so it means that anode oxidation takes place. So the same goes for the case of galvanic cell as well as the electrolytic cell. So that is for your anode. For your cathode here, so cathode is your negative electrode, which is the electrode connected to the negative terminal of your battery. And then remember, cathode, red cat. So red cat means that the reduction takes place at the cathode. Okay, so here is actually your example of your electrolytic cell. Again, there are electrode which is connected to a battery. Okay, and then the anode is the one where we connected to the positive terminal. Cathode is the one connected to the negative terminal. Okay, so still follows the ABC rule, tapi in this case anode, battery, cathode. Okay, but for the case of electrolysis, when we're talking about the your aqueous solution, for example, here I have my aqueous, my MX solid, for example, my MX aqueous. Okay, but for the case of aqueous, there is always the presence of water as well, because when we're talking about aqueous, it means the electrolyte contains water. Okay, so for example, MX. Okay, when we dissociate it, it will become M plus aqueous plus X minus aqueous. So M plus is my cation. So here cation is attracted to cathode. My X minus is actually my anion. So anion is attracted to anode. Okay, and then the water itself consists of H plus and OH minus. Okay, remember, cation, the positive charge is attracted to cathode. Cation, cathode. Anion, anode, where the anion, the negative charge is attracted to the anode itself. Okay, so that is for the introduction of electrolytic cell. Okay, so again here, I just want to show it to you. Okay, electrolytic cell is a process where it will convert electrical energy to the chemical energy. Okay, so what does it mean is that, okay, this reaction needs an electric, where the electric is provided from the battery for the reaction to occur. So chemical energy means that chemical reaction lah. Okay, so this is actually a non-spontaneous reaction. Okay, because we do need the battery for this reaction to occur. But it still follows the ABC rule because anode, but then here does not this is battery, C cathode. Where the cathode is the negative terminal and the anode is the positive terminal. Okay, so that's for electrolytic cell. For galvanic cell, still follow the ABC rule, but here we don't have any drawing of our bridge kan. Sini sepatutnya adanya salt bridge. Okay, so for the case of galvanic cell, it's the other way round. it will convert the chemical energy to electrical energy. Okay, so what does it mean is that for this reaction, for the reaction of galvanic cell, okay, once the reaction could occur, then we will have an electrical reaction. So that's why we can have a reading on your voltage. Okay, for the case of galvanic cell, it is a spontaneous reaction. Okay, for this case, spontaneous is the positive terminal while anode is the negative terminal. Okay, so that is the differences between our electrolytic and galvanic cell. Okay, last but not least, what we're going to look at is actually the similarities. So again, for this case, what is the similarity? So what is the similar? Similar is actually oxidation occur at anode and reduction occur at cathode. Anox, red cat. Okay, and then electron will follow, okay, based on the A, B, C. Electron will flow from anode to cathode. Okay, so that is the introduction. Okay, next what we're going to look at is actually, we're talking about electrolysis. We will look at several factors regarding the discharge of the species at the electrode. Okay, so on your notes on page 14 here are the factors affecting the discharge. First one is the standard reduction potential. Okay, the more positive E0 will be easily reduced at cathode. Because remember, when it is positive, it prefer to be the cathode. And remember, red cat. So it means that the more positive, it is more easier for the species to undergo reduction. While it is more negative, it will be easily oxidized, because more negative, it means that it will be at anode and also oxidization. So when it is more negative, easier to oxidize. Okay, so that's the first one. Okay, the second factor that we're going to look at is the concentration of ion. The more concentrated the ion, the easier the species to be discharged at the electrode. Here is for the case of halide ion. Halide ion for our electrolysis usually Cl- or Br-. Okay, and the last one is the nature of the electrode. Where most of the reaction, we will always use the inert electrode, the carbon or the platinum. Inert electrode is where the example, as you can see in the equation, the platinum or the inert electrode is not used in the equation itself. Okay, but then when an active electrode is used, usually copper or silver in our syllabus, it will get involved in the reaction by dissolving as iron. So here is actually the case of our electroplating. Later we will look at the example itself. Okay, so before we look at the specific example, okay, how to predict the product of the electrolysis? First step, you have to identify the movement of ion present. You have to determine, because from here we know that we're talking about the ion, the anion and the cation. So for the species, first thing first, what we have to do is determine the species. Okay, next, at the cathode, we will choose the ion with the higher E0 cell, as it is easier to reduce. Again, the same case as this one. But reactive metals, sodium and potassium are never produced. Because this is a reactive metal, we will not choose sodium or potassium. Even though it's concentrated or not concentrated, we will never choose this one. Okay, but the case of anode, here we have a lot of condition that we have to look at. Okay, which is the type of electrode and the concentration of ion, which is this one. Okay, by default, what we want to do is to choose the ion with the lower E0 cell. But then there is an exception for electrolyte that contains high concentration of halide ion, this one. And then for the case of active electrode, we will choose the active electrode because it will dissolve to form metallic ion. Okay, so here is actually the summary where at the end of when we have learned all the reaction, we will do it together. Okay, but then for our syllabus, the electrolysis that we have to know is 1, 2, 3, 4, 5 for the equation as well. Okay, so without further ado, let's continue with your notes on page 15. So let's continue. Let's start with the first one, electrolysis of molten salt. Molten salt is the salt which is melted. So that's why we call it as molten salt. It requires high temperature for the melting process, but there is no presence of water. Okay, so here is actually the apparatus for the electrolysis of molten salt, which we need heat because of the high temperature. Okay, and then here we have our inert electrode, which is our carbon, and then here is our molten NaCl, which is molten salt. Okay, so first let's write down the equation itself. So for the equation, for the salt, it is solid. So when we dissolve it, we will get Na plus Cl minus. But how about the state? Because if you write down the aqueous, it's incorrect. Okay, why? Because here is no presence of water. Aqueous, so it means we have water lah. Okay, for molten salt, salt is melted. So when you melt it, we're talking about from solid to liquid. So here, the phase for our ion is liquid. So from the ion here, the species present for the case of electrolysis of molten salt, we have Na plus liquid and Cl minus liquid. Okay, so first I'm going to write down the anion and the cation itself. So anion is Cl minus, cation is Na plus. Okay, so for the case of anode, it will be anion, cathode will be the cation. So I'm going to write down the species itself first. Okay, how about the state? Remember, molten salt is the liquid state. Okay, right now let's do the equation. Oxidation is losing, so losing electron. Okay, but then again, what is the product? Okay, chlorine, the stable element, is actually not Cl solid, it is Cl2 gas. So that's why Br minus the Br2 gas. Kalau H plus, the stable element is H2 gas. So Cl minus, stable element Cl2 gas. Next, what we have to check is actually whether the equation is balanced or not. Okay, so first check the atom. Okay, so here chlorine 2, here 1. So to balance it out, 2 chlorine. Okay, after that, we can check the charge. Okay, the charge here, -2, -1, 0. Okay, so we want the charge here to be -2 on both sides. So right now we have -2 on both sides. We can continue with cathode. Cathode is the reduction where we gain electron, Rig. So plus electron. Okay, the stable element for sodium is actually a solid, because sodium is actually group 1 element. So group 1 element is the metal which is solid. It is applicable for group 2, for example magnesium, or group 13 aluminium. Okay, so that is for the metal itself. So here is the product, metal solid. So make sure the equation is balanced. The atom as well as the charge itself. The charge on both sides will be 0. Okay, once we have checked the equation, next for the overall, we have to simplify it, but make sure to simplify, the electron must be the same. Okay, so when electron must be the same, so we have to multiply this equation by 2. So we have to multiply here 2, then we can lose or gain the case of transfer of 2 electron. Okay, so here I'm just going to simplify it. The equation, the reactant must be on the reactant side. The product must be on the product side. So 2Cl minus liquid plus 2 Na plus liquid, we equal to Cl2 gas plus 2 Na solid. Make sure it is balanced. Look based upon your equation here. Okay, so that is the equation. Okay, observation. How to write down the observation? Observation, you will refer to the product of your equation. Okay, so electron is not included. So here we have chlorine gas. So you have to write down chlorine gas is produced. So it's fine just like that. You don't have to include this is the green color, no need. Just based upon the equation itself lah. Straightforward sahaja. Okay, so for the cathode, let's look here. So here is our sodium metal. So I'm just going to write down sodium metal produced. Or sometimes in notes, it like to write down deposited, but it is the same meaning. It means this metal is produced. So that's the case for molten salt. Molten salt is quite straightforward. Okay, next we have to look for electrolysis of water, where it will decompose to O2 and H2. Okay, so first what I would like to write down is actually the equation itself. H2O liquid will form H2 gas plus O2 gas. But the equation is not balanced yet, so what I'm going to do is actually balance the oxygen. So 2H2O, 2H2. So here the equation is balanced. So the overall we get this equation. But how do we get there? That's actually quite a long step. Okay, because the composition of water. Okay, but then the species present for this case is only H2O. We don't have any ion. Okay, but then you know that, so that we know that the H2O and H2O must be the anode and cathode, the reactant. You know that the H2O consists of H plus and OH minus aqueous, right? Okay, so here is actually, these two must be present in the product. So how to know it? So here is actually the hint for you to remember. Okay, so for anode, okay, when you realize it in the middle there, anode is O, O in the middle. So it means that we have oxygen on the product. For the cathode, okay, when we check it in the middle, it's H. The middle letter will be the gas present. So here will be H2 gas. Okay, so fine, we have done the gas, but how about the equals? H plus and OH minus. Okay, here easier. Cathode, we have OH here. So the cathode has the presence of OH minus, hence the O2 has the presence of H plus. Okay, so that is the equation. That is the product that you need to have in the equation. Okay. Okay, so that's the product. Okay, nanti kita kena balance Then still we have to balance it. Okay, remember anode oxidation we lose electron. So I'm just gonna write down losing the electron first. The cathode is actually a reduction process, red cat, where it will gain electron. So I'm just gonna plus electron. Okay, then will be the arrow of product. Okay, so again, what is the product? Here for anode, in the middle here, we have our oxygen, so plus O2. Cathode, we have H, so it plus H2 gas. Have to write down the state as well. Okay, next is actually the ion. Okay, ion, cathode, OH plus OH minus equals. For the anode, so it means that we have H plus equals. So that is the equation. But how to balance it out? We have quite a lot. Okay, so let's do a bit of revision of what we have learned during semester 1, chapter 1, oucher, when we balance the redox equation. Atom, charge, atom, oxygen, hydrogen, C, charge, E, electron. Okay, so first, oxygen, when we check it, oxygen is not balanced, so make sure the oxygen is balanced. Next is hydrogen. Hydrogen here 4, here is only 1. So we have to add 4H plus here. Okay, next is calculate the charge. Okay, I'm just going to write down using the red pen. So here is 0, 0, positive 4. Okay, so here positive 4, reactant is 0. So we want the overall charge to be 0. We have to add 4 electrons. So when you count it again, you will get 0 on both sides. Okay, for the cathode itself, first check the oxygen. Okay. Hydrogen. Okay, hydrogen is not balanced. So how? We want to make it even. I want to make both sides to be 4. So 2H2O. Okay, here how to get it 4? Actually H2 gas, just let it be. OH minus ni we add 2. So when we check it, both sides hydrogen will be 4. But then again, check the oxygen. Both sides we will get 2 oxygen. So it is balanced. But then calculate the charge. Here 0, negative 2, so it means product negative 2. The reactant must be negative 2 as well. So we have to add 2 electron. Okay, so that is the equation. So that is only the equation per anode and cathode. Okay, so that is the balanced one. Okay, next we have to simplify for the overall equation where the electron must be the same. But then the electron is not the same. What should we do? We have to multiply all of this by 2. So for the overall here, I'm just going to copy paste again. Okay, this one I haven't multiplied by 2. So make sure. So jadi 4H2O, 4 electron, 2H2 and 4OH minus. Okay, so we can simplify it by first simplify the electron itself. Okay, and then remember on the same side, we'll be adding the species. If on the opposite side, we will be removing. Okay, so for the H2O here, we have on the same side. So 4 plus 2 is 6. So it will first 6H2O liquid. Okay, the electron is being removed already. Okay, we have our O2 gas plus 2H2 gas. And then we have our equals. Remember that H plus and OH minus actually will form H2O liquid. So I'm just going to write at the end here. H plus equals and OH minus liquid will form H2O. So here, I will straight away form my 4H2O liquid. Okay, but then from this equation, actually we can simplify it further. So how? Simplify the H2O, which the opposite side, which can be cancelled out. So 4 can be cancelled out. What is left is 2H2O. So the last equation is 2H2O liquid equal to O2 gas plus 2H2 gas. So that is the overall equation. Okay, so when we check it again at the start there, the composition of water H2O to O2, we get the same equation. There's quite a lot of steps for you to know to get the answer. But then that is the steps lah. Okay, so the step, but then remember the product. That is the tricky part. Okay, remember the middle of the letter must be your gas. Then the cathode must be your apa ni? The ion refer to the cathode OH minus, so it means that anode H plus. Okay, and then make sure you have gain all loose electron. Yang itu memang kena black cat, rig, and ox oil. Okay. Next, what about the observation? Again, observation must refer to the equation of product. Okay, first when we look at anode equation, there we have O2 gas as well as 4H plus aqueous. First, write down oxygen gas is produced. Okay, next, we have the presence of H plus aqueous. So we have to mention that the solution is acidic. Whereas for the cathode, we have H2 gas. And so we have to write down hydrogen gas is produced and OH minus. For the OH minus, we have to write down the solution is basic. Okay? Okay, so that's it for this video. We have to look at the electrolysis of molten salt and the water.